New chapter. Okay, Assalamualaikum warahmatullahi wabarakatuh. We're going to continue on the chapter network layer. So we already discussed on the IP address, network address, public and private IP addresses. So we're looking at right now we are looking at the why IP addresses is in crisis right now. So it's because of IP addresses depletion. Because of right now we have million of devices or hosts that connected to internet. Maybe I think it's not million, it's maybe billions. So we are having an IP depletion, and the internet routing table is exploding. So that's why uh, IPv4 have a new feature, which is the subnet mask. So one solution to the IP address shortage was thought to be the subnet mask that we're going to discuss and do exercise on it in this week. So the subnet mask breaks a single class A, B, or C network to a smaller pieces. So for example, class C, you can have a host up to 256 IP addresses. But if you have a network less than 12, for example, in your home or in your lab, so you can break these classes, class C, to a smaller pieces using subnet mask. And then other features are CIDR, classless interdomain routing, and VLSN, variable length subnet mask, which will be discussed inshallah next week. So let's look into an example of the subnet mask. So in case of class A and B IP addresses, each of them provides for a large number of hosts. For class A, the total number of hosts available are 2 power of 24 minus 2, or 16 million plus plus. Out of total value, one address is for the network. Similar to class B addresses, which provide 2 power of 16 minus 2, or 65,000 plus plus hosts. So in the first chapter, you learned that about the advantages of large network and why it become necessary to divide them into smaller network joined by routers. So creating a network with total number of hosts allow for class A or class B will cause a lot of problem. Meanwhile, creating small network with class A or B addresses will waste a lot of addresses. So to overcome this problem with class-based addressing, subnetting is introduced. Subnetting allows you to borrow some host bits and use them to create more network. So for example, you have a class A which huge a lot of hosts, so you can divide it into multiple or new network. We call it subnetwork. So these networks are commonly called subnets or subnetwork, and are smaller in sizes. To further understand how subnetting is useful, consider a class C address. Each class C address has 2 power of 8 minus 2, or 254 host address available. If you want two network with 100 addresses and use two class C network, you could waste around 308 addresses. So instead of using two classes of network, C network, you can divide one class C network into two subnetwork. So each network can have 127 addresses each. This way, lesser number of addresses will be wasted. So there are few benefits for subnetting. First is reduce broadcast While broadcasts are necessary, too many of them can bring down a network, and the number of broadcasts is proportionate to the size of the network. So subnetting a network to smaller subnetwork help reduce broadcasts since routers do not forward broadcasts. It also increases network performance. The direct result of reduced broadcast is a network that has more bandwidth available to hosts. More bandwidth and lesser host value result in better performance of the network. The third is easier management. So managing and troubleshooting a large network is cumbersome and difficult. Subnetting breaks a network into smaller subnetworks, making it easier to manage each of them. And lastly is scalability. A single large network spanning a large geographical location will be more difficult and costlier to manage. One link connecting different locations are costly and having broadcast choking the network. Hence, breaking down a large network make it easier to scale a network across geographical location. For example, in UTHM, it has large network, a few thousand of hosts or computer. So that's why it divides those hosts into subnetwork. So creating another section in the IP address is called the subnet. In case of class-based subnetting, the first octet of the dotted decimal address tells which part of the address is the network component and which one is the host component. However, when host bits are borrowed with subnetting, the class-based boundary do not apply and it is not possible to say which bits are network bits. To overcome this, a third component of IP addresses were added. These are called subnet masks. So subnet masks, like IP addresses, are 32-bit long. The value of subnet masks represent which bit of the IP address are network component and which are host component. So a value of 1 in the subnet mask shows that the corresponding bit in the IP address is a network component, while a value of 0 shows that the corresponding bit is a host component. So let's look into this example. If you have IP address of 192.168.10.1 with a subnet mask of 255.255.255.0, you need to make it easier to understand, you need to convert this decimal to binary, and then you know which bit is the host and which bit is the network. So from here we know that the first 3 octet or 24 bits, the first 24 bit is the network component, while the last 8 bit here is the host component. And we know that this is class C, where the network mask is 255.255.255.0, similar to the subnet mask. Let's look into the second example. An IP address of 172.16.100.1 with a subnet mask of 255.255.128.0. So first you need to change it to the binary. So it will make easier for you to differentiate differentiate between the network and host. So from here we know that the first 17-bit here is the network component, while the last 15-bit here is the host. And we know that this is basically, before it's subnetted, it is class B because the IP address start with 7172, and the network address, the network mask which is for the class B is 255.255.0.0. Okay, so make sure that you can differentiate between network mask and subnet mask. So the network mask, it depends on the class. Is it class A, class B, or class C? But the subnet mask, you need to look at the binary here. So you need to convert it to binary and see which one is the host and which one is the network component. Okay, let's make this. I'll try to do this for example. So an IP address of 192.168.10.1 with the subnet mask of 255.255.255.224. So let's convert it first to binary. So this has been converted to binary. So you can use calculator to convert it. 255 is basically 111, 8-bit 1 in one octet. So from here, the network component is the first how many? 24, 25, 26, 27. So 27 bits. And the host component is the 5 bits. 5 last bits, 0. This is the host component. And we know the class is, if you look at this number here, it is class C. And the network mask should be class C is 255.255.255.0. Okay, it's simple. Let's try to do this also lah. So an IP address of 10.1.1.1, there's too many one here, should be only 4 octet with subnet mask of 255.255.0.0. So let's convert it to binary. So this is the binary number. So the component, network component is the first 2-bit here, which is we can write it down as the first 2 octet. And the host component is the last 2 octets. So for class, it is class A because it starts with 10. And the network mask should be for class A is 255.0.0.0. So if you look at this, the network mask and the subnet mask is different. The network mask is class A, while the subnet mask is much smaller than the network itself because it has been divided. So this is another example. So for example, you have class B, you have 2 octet, first octet is the network, the last 2 octet is the host. So the subnet mask will be in the host. So means that you subnetwork the network itself. So the host becomes smaller, the number of hosts becomes smaller, and you use the part of the host to be the subnet. So subnet masks are commonly represented in 2 ways, using dotted decimal. This is the IP address, and this is the subnet mask. Or you can use classless interdomain routing CID bar notation. So you just use this /16. So /16 means 10.1.1.1/16 is basically equal to 10.1.1.1. You should have 16 bit of 1, means that you have 16 bit for network component. 4, 5. Okay, like this. So means that you have 16 network component and the balance is the host. So by now you may have figured out that default network mask of class A is /8, class B is /16, and class C is /24. So that's how you know your subnet mask knowing the by using the classless interdomain routing notation /16/24/8. So it depends. So this does the notation converted to the decimal value.